Alright, so the next lab that we'll be working on, it's an experiential lab to get you to try your hand at soldering. And what I'm going to be doing is going through some of the materials that you'll be using, and I'll talk about some of the challenges that you'll have, what to watch for, what to avoid. So I'm going to start off with this particular project. I want to repurpose this board, and it had something previously soldered onto it, so I'm going to desolder it and show you how that's done at the same time. Let's change that angle up a bit. Yeah, I should be able to see that a little better. Okay, so I've got a soldering iron, and my soldering iron is in a proper holster, and it's got some brass to clean the tip. When you're soldering, one of the things you've got to do is prep your tip. You shouldn't use it as is, because what can happen over time, you'll get it build up and then you won't be as accurate. So frequent cleaning of the tip is essential. And the second part is that this particular unit is rated at 30 watts. So the size and the strength of the soldering iron is important, in as much as how much you're going to actually be soldering and what temperature. You can get a gun. Just going to move this aside for a second. You can get a soldering gun, and a soldering gun is handy. It does work well. It takes a bit of patience, because you have to wait for it to warm up before it does have a light. But I want you to notice that this is 100 watts. Now that's a lot of heat that is far more than necessary. I've actually bought a new soldering iron that is got less wattage. This is what the original, what this one looked like prior to abuse, and you can see when I compare the two tips, just move that one out of the way, you can see that this is a finer point. It's going to get the heat onto a smaller surface, where this is basically hitting it like a club. So they both have the purposes. Like, I use this one to desolder because I'm not really concerned about neat and tidy. I use this one, I heat this up, and I use it for actually soldering. I've also went out and purchased a even smaller unit that only does 25 watts, because when you're working with the circuit boards, what you'll find can happen is, as you're working with it, you can actually melt the trace off of the actual printed circuit board, and once that happens, well, you can't solder it to. There's nothing to solder to. So what I'm going to do is I'm going to just turn this around. Now this little device that I'm using, this apparatus, it's called Helping Hands, and it's for middle-aged people like myself whose eyeballs don't work quite the same way they used to. But if you're going to spend the money, get a better one. This is more for demonstration than anything else. It's a little awkward to use. It does work, but the problem is it's not got a heavy enough base. It was only $20, and I got it just for demonstration. I don't do a lot of soldering, so just to demonstrate what it is I'm attempting to do, to show you how to solder and desolder and the like. Now, on this particular case, when I go to desolder, I won't be able to really use it, because I've got to put pressure on it, and the second I put pressure, it's going to fall over. So I'm going to take that off, and I'm going to pause the video. I'm going to get a piece of wood. This is a non-flammable surface. Normally when I do any videos like this, I have a black piece of fabric down, but I'm not going to put a fabric where I'm going to be soldering. So I'm going to pause the video, and I'm going to get a piece of wood to actually do the soldering on. Alright, so I've got a piece of wood. My soldering iron, I can feel the warmth coming off it already, so it's ready to go. Now, to get the old solder off, it's called desoldering it. There's a couple of different methods. I used to have a squeeze bulb. I lent it out. It never came back. So now I'm kind of stuck to do it the two other ways. Now the first way you can use is what they call, this is solder wicking. And what it does is because hot tends to go to cold, you want the solder to, put that back for a second, you want to use the solder to your advantage. The other thing that you require is a solder paste. Now there's a bunch of different brands, etc. I just picked this up. Notice that it's lead free, etc. And that's just to kind of dress the tip. Doesn't take a whole lot of work. I'm going to clean the tip. Kind of maybe give that a better view of the soldering iron. And I go to do that little thing. See my fat belly there. Okay, so I'm going to be cleaning this off on a regular basis. I'm right-handed, the camera's on the wrong side. So to do the desoldering, you take the solder paste. Now this heat is going to wick. So keep in mind that when you start desoldering, it's going to get hot and quite quick. So you just want to use the copper braid. Give yourself a bit of playing room here. And just press it on top of the solder. Let the heat do all the work. Doesn't take a lot of effort. I'm just tapping it, and you can see now, I can see the center hole. There should be 3 holes if I've done my job right. There's 3, excellent. And it already has reached my fingers. It doesn't, this is why I say you don't need to have a huge amount of heat, especially working on these boards. They're very small. So I'm going to desolder this. And you can see it's just wicking right straight through, and it's just pulling it off. I'm not applying a lot of heat. I'm not forcing it. So that's one method you can use to remove the solder. The second is a squeeze bulb or a squeeze gun. This looks like a hypodermic needle, but you just depress it, and now it's loaded. Once the solder gets to be in a liquid state, press the button and it sucks it back up. And repeat. Now, it can be a bit tricky because you're working with the solder. It's getting hot and you're trying to vacuum it at the same time. You can see that this is where those helping hands would come in handy if they're a little stronger. I'm used to using the wick, so I'm just going to carry on and finish desoldering this. And again, it does not take a whole lot of effort. There is in the classroom solder wick, and I have solder paste. Doesn't hurt to keep your tip clean. Even desoldering, it doesn't hurt to keep taking the excess solder away. And you can see I'm just holding it for a few, like not even a 5 count. Just touching it. It's not a race. Okay, that's looking like that's almost ready to pull out. Oop, missed one. See, with a magnifying glass would be really handy. And then I've got a couple of strays over here. Heat is not electronics friend, which is why you want to use as little as you can. All you're trying to do is to liquefy the solder. You're not trying to weld. That's why they don't call it electronic welding, they call it electronic soldering. So this particular case was an excess, and when you get an excess you can end up soldering the wick to the board. So I'm going to put this aside. Pasty, cleany, cleany. Let that cool off and see how I'm making out on this side. So all of these connections have to be upright to get them to come out. Tweezers would have been a good idea. When you solder, this leaving of these long tails is not a good idea. You want, once you finish soldering something in place, you let it cool, of course, and then get rid of these tails, because all of these were touching this, which is a common, and you could use that as a chassis ground, and you probably don't want that to be grounded there. Okay, let's get rid of this up here. Now, speaking of solder, while I'm taking it away, there is different types of solder depending on what you're doing, and the newer solders are they've gotten away from using for houses anyway. They don't use lead for the water anymore if you're doing copper pipe. They've actually, a lot of houses now don't even have copper pipe. They've gone to what they call PEX, it's plastic. There's still lead in electronics, but you can see that basically there's so little involved. It's you'd have to be doing this 16 hours of the day in poor ventilation for it to become a problem. But for the number of times that look, when we do it in the classroom, there's masks outside the door, and I recommend that you use it. I do not have any masks. I ran out. But as I say, I'm not doing a lot. Just a quick demonstration and then Uncle's your Bob. Okay, I'm going to finish this up and we'll get into the soldering in a minute. Alright, we're back, and you can see I was successful in getting the devices off of the board. These can be tricky, and especially when you look at these printed circuit boards, you're going to see that there are a bunch of these little holes that are lined up sort of like your breadboard. They've got commonality to it. When you start putting them on the board, you're going to start running into some really tight spaces. One of the devices I took off was a socket for an IC chip, and the trick with doing that is you bend the leads slightly just to hold it in place until you get one or two points soldered, and then you don't need to bend them over. The person who did this from a previous class bent them flat, and that presented quite a bit of little extra work, not a big deal. It doesn't look like I've damaged any of the tracing on it, so the whole board's good to me. And what we're going to be doing is we're going to be making something that looks sort of like this when it's done. I've removed one part. I'm going to have you take a look at this. This is actually the next subject we're going to be taking after the midterm, but this is kind of a little bit ahead, and I want to use this to our advantage. This is called a diode, and I'm not sure whether you can see it in which camera the best, but you'll notice it looks sort of like a resistor, but it has a silver stripe on it. And if you recall from working with our tester, I call it the hole in the arrow in the wall, that's basically the silver stripe is the wall. That's the negative side. That is the cathode. This is the anode. And diodes are designed to actually filter AC. They only allow DC to pass through. And what we're going to do is we're going to create, I've taken this one out to kind of show where it's going to go. I want to make sure I put it in the right way. Hands to hands, tails to tails, okay, that goes like that. It goes something like this. So this is what they call a bridge rectifier. And I drew on the blackboard a Wheatstone bridge. Similar idea. You're making two parallel circuits, but the current is forced to go in a particular pattern. And as for example, it comes through here, now it can't go through there, so it has to work its way around through the common and back, and it works its way out so that you end up with two half-wave rectifiers that take an AC waveform, an alternating current waveform, and converts it into a single full-wave rectifier. Now when we do the lab, I'm going to have you actually wire up solder up an extra wire, because the first part of the lab that we're going to do when we get to the diodes is we're going to be applying an alternating current source from our function generator through a single diode. And we're going to look on the scope and we're going to watch it and see how it reacts. So this is the basic circuit that we're going to attempt to solder together, and I'm going to have you put an extra lead on it so we can still just look at the one diode as well as looking at the entire bridge rectifier after we've done the work on the single diode. We're going to use the full one. I just added these as kind of decorations. Normally with bridge circuits you apply it on the tops here, but it's the output comes on the corners. And if you're doing if you want to build a Wheatstone bridge, you would replace the diode with a potentiometer, and you would actually take your measurements from these 2 points. If all of these were exactly the same in resistors, you would expect to find there'd be no potential difference between these 2 points. That's how the Wheatstone works. If you alter one of the legs, then you end up shifting the way the voltage works, and that determines what the circuit will do for you. So I'm going to pause it again. I'm going to lay this out on my other breadboard, and you're going to see it in reverse, and then we're going to start soldering, and I'm going to point a few things. Before I do that, let's take a minute, because I've got all this other stuff lying about here, and I've got various types of solder. I've already shown you the wick. Set that aside. And I've also got different other formats from previous soldering expeditions. So I'm going to point out a few things about solder. First of all, you do have to get solder paste. There are different types of solder. There's plain solder, then there is what they call the core fill, and the core fill has either acid or rosin in it. Now, doing electronics, if you use acid core, you'll destroy it. So make sure it does not say acid core. Acid core is primarily used for plumbing. And when you're doing acid core, I'm going to show you, this actually says electrical on it, but I want to show you on this here. You can see how thick this actually is. I mean, that's a very fat, thick solder. That's good for making like a solid copper to copper joint. They call it electrical solder because it has rosin core, not acid core, and it's what they call a it's an alloy. and it gives you the percentages. Here it says that 60% lead and 40% tin. Now, if my voice sounds slightly muffled, I actually went and found a mask and said, okay, you know, practice what I preach. You should wear a mask, and I are wearing a mask. And hey, see how much I spent on this. Solder's not exactly cheap. It's better to buy it on the roll. But I just wanted to show you. Let me see if I can just coerce a little bit out, because this is going to take a lot more energy and it'll make a bigger mess. So you can see that's the solder for, you know, larger ones for repairing electrical equipment as opposed to electronics. And this is like half the diameter. And this is all you need, which is why I've unplugged this solder. Clean that up a bit. What a chocolate mess. But it still does the job, and it's still warm. I'm going to set that aside where it's not going to set anything on fire. It's not that hot. It's been off for about, well, maybe 8 minutes. And this is what I'm going to be using to do soldering. Notice that the point is very small. That transfers the heat and focuses it. If you want to look at the board, it can practically fill in one of the holes. So it does not need copious amounts of heat. This particular one is another 30-watt one, and in fact it's almost too much. The smallest I've seen is a 20-watt. I'll grab my other one here. I haven't even had a chance to use this one yet. Just to give you an idea, because as I say, when you're working with electronics, you don't need... Yes, I'm just opening the package. Okay, so comparing the two tips, the tips are virtually the same. It's just that this is not going to be pushing that much heat out as this one. This is only I think this is a 25 watt. I didn't have any 20 and stuff. No, this is the 20 watt. I did take the 20 watt. Excellent. And it's got a bit of a heat reflective shield on it in case your hand slips. You're still going to burn your fingers. These are designed so that you can't slip, put your hand in place, which is painful. Trust me, I've been there. It's not a very good movie. Okay, so getting back to the solder, you want it to be thin. When you go to buy it, it's going to tell you what's in it. So this is where you get the numbers of your, this SN is tin, PB is lead. So this is 6337 tin to lead. This is a 6040. They've got different colors to let you know. This is old school. Kester, I remember it when I was a teenager. Long, long time ago. Made in Bradford, Ontario. Awesome. It's almost a clicker. And again, it's 6040. It's a flux, and this is a rosin core. It's not acid core. I don't have any acid core. You'll also find it sold in packages. And again, this is another package that I picked up, and you can see how thick that one is compared to these ones. I'm not going to say this is a thin. This is about the 22 gauge wire size, but just when you look at the two of them, you know you're going to use a lot more energy and frustration. And think of the size of the target. I mean, that's about the same size as the target. We don't want to use this one, because it's going to actually bleed over when it finally melts. It's going to bleed over and short things out. So the smaller the solder, the less the heat, the easier, and it's just a quick little dab, and little dab in your will do you. This is actually a handy method of using it. This particular one is tin lead. Doesn't give me the percentage on this. Oh, 60-40, 60-40, 60-10-40 lead. It's easy to pull out, use a bit, pull a little bit more out, etc. Comes off, I can replace it. And what I did was I had a big piece of, this is actually plumbing solder from when I did some plumbing at home. You can see how thick that is. That's like, I'm going to say that's number 10. dryer size wire almost. But because the spool was running out, I used it to wrap it around. I'm going to take this when I'm done and do the same thing, because this is a handy way of dispensing it. You can keep control of the solder at the same time. When you're doing it this way, the problem is you're using your fingers, just like the wicking. Hot goes to cold. My hand's cold. Solder is hot. It will travel. This is a good conductor. That's why we're soldering it, because it's a good conductor. We don't solder in insulation. We put in conductors. These, when I took them off, as you probably found during the other labs working on them, these resistors will get warm. Anything that you're passing that heat's going to go wherever it can, and your fingers will get burnt if you're not paying attention. Okay, so I'm going to plug in my other soldering iron, and then we'll pick up the story shortly. Alright, we're back. So, I've got my first piece here, and I want to point a few things out. We're going to eventually make that diamond shape, but when we're working on this, you have to keep in mind the traces on the back. So I'm going to flip this over, and you can see that I have my wires poking up. This one's bent over a little bit much, probably because of what weight on it. You just need to slightly push them off to the side. Not a lot, just a little bit, just to hold them in place. And you've got to think in terms of the next one and how many connections we have. So if this is the first one, I'm going to have in the middle 2, but on the end I'm going to have 3. So I want to make sure I give myself some room. And you can see already I've got this kind of in the wrong hole. If I'm going to have to put 2 more wires and use that trace, I'm kind of in the wrong spot. So if you hold it up to the light, you can see through it. Take a little bend out and move it back a couple. There we go. If you pre-measure it, you can trim it, and you can have a nice straight looking professional device. Normally on a real board you would not leave that tail that long. This is just so we can visually see it. And you see I've got it just slightly pushed off to the either side. Not a lot. It's not going to fall out. Now I can go ahead and solder that if I want. And you'll see if my soldering iron is, oh, it's making smoke. Smoke is always good. That means I've got some heat. And I'm going to take my little tiny amount in my one hand. And what we're trying to do is we want the solder to wick to where it has to be to actually make the solder, the actual joint. But we don't need a whole lot, as I said. We're not welding anything. All we're doing is just melting a little bit of solder to do what it has to do. So we're going to put this off to the side. I've got fresh solder paste on that, which will help it to flow. And I'm going to put the solder towards where I want it to go. When I want to have the heat, get a little bit on my tip. Done. That was all there is to it, just like that. Now, here's the thing. I wish I could get this really, really close. Let's see if one of these cameras can get ridiculously close. That's too close. Doing that 3D thing. Okay, so where's my camera head? Again, I'll have to bring that down. What you're looking for is right here on that solder that I've just done. I'm not in range. Okay, give me a second here. Okay, this is really kind of hard to show you. What you're looking for is a little volcano. If you make this shape whereby it just flows on either side and makes that a little tiny volcano on it, that's a good solid soldering joint. So let me just see if I can make another one here. I'm going to swap hands because I'm a righty, and a little dab will do you. A little bit of solder. That one's done. So you can just see, it's not a huge amount. I'm not overloading it. So let's get my next diode. When you're doing this, the trick with making a rectifier is on two of them, you're going to go tail to tail, or the proper term would be anode to anode. Notice how I double check them in the same little row. Excuse me. Then the other one where I guess it's going to be. Now here there's no connection this way, so I can go in that quadrant or row, turn it up so I can see some light. I want to get close to the inside on that same column, just because it's going to look better. And bend it out of the way. I'm going to trim these afterwards. And that's my cool down one. Take my solder, take my soldering iron, stop banging the camera. Okay, bit of soldering paste, prep the tip, right up close, done. Done, and I think, yep, that hole is still clear. And I haven't filled the other holes. So I've soldered it. I've got that beautiful Hershey's Kiss look, the little volcano. So I'm away to the races. So when you do the next two diodes, they're going to complete that diamond shape. But first these ones are put tail to tail. The next two still going to be on that same on the top here. So I'm going to poke that one in there, and this one is going to be nose to nose. When we say tail to tail and nose to nose, we're talking about from the viewpoint of the center that we're working with. So I'm going to put that, and I know I've got 3 on that, or possibly 3, so I'm going to use the middle one. Is that on the same? Yeah, it is. Okay, good. That. And I'm going to be a brave individual. I'm going to grab this, stretch it out, and I want it to go nose to nose, because everybody knows that's what you're supposed to do. And I want to go on the inside of this other one. Didn't plug that hole. Great. Okay, nose to nose, tail to tail. Now I'm going to hold it with my finger on this side just until I get the little prongs just slightly bent. Again, I'm not trying to kill it, as it were. I just want it to stay in place until I get the solder, and then I can do my trimming. Alright, genius. Flux, 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 flux. No muss without the flux. Turn that a little sideways. Now you see how that turned into a little ball? And I took a little extra heat and coercion. If it forms a ball, you don't have a solder at all. Two volcanoes, excelente. That one looks good. Volcanoes, volcanoes. I'm missing my one Hershey Kiss. Okay, so I'm going to go here. Awesome, awesome sauce. So I have 8 Hershey Kisses, which is up to this point perfect. So now I have that resolved. So the only thing I've got to do is I've got to put in my 2 leads. What I might do is actually get you to solder in a switch for another lab later, because on those little breadboards, the switches that they give you, the nice way of putting it is they drive you crazy because they pop out. So one's going to go here. Nope, it's got to go up on the top and the bottom. So this is going to be my negatory, and this is going to be my positivo. And so the power is going to flow towards here. It can't go this way, that's reverse bias. So it's going to go into the circuit, it's going to come back, and it's going to find a way to get back through here. So our load's going to go across here, back through there, and that's going to complete one circuit on the one way, and it's going to go this way on the other direction. It's going to make that zigzag. So our load that eventually we're going to do our testing on, if I were to put a resistor in the LED, it'd look something like that, so it would do a zigzag. Anyway, I'm going to put the other wires in. That's all there is to soldering. Again, safety first, keep your fingers away, use the stands. It's not a race, there's not a competition. If you get this far done and you get 4 beautiful solders and you're happy with it, then life's good. Because even if you left that alone, we can still do the lab just by putting the alligator clips on one of them. So that's all there is to soldering.